The second law of thermodynamics. Experimental evidence suggests strongly that it is impossible to build a heat engine that converts heat completely to work. That is an engine with 100% thermal efficiency. This impossibility is the basis of one statement of the second law of thermodynamics, and it states that it is impossible for any system to undergo a process in which it absorbs heat from a reservoir at a single temperature and converts the heat completely into mechanical work, with the system ending in the same state in which it began. So, we will call this the engine statement of the second law, or it is also known to physicists as the Kelvin-Planck statement of this law. So, the basis of the second law of thermodynamics is the difference between the nature of internal energy and that of macroscopic mechanical energy. In a moving body, the molecules have random motion, but superimposed on this a coordinate motion of every molecule in the direction of the body's velocity. The kinetic energy associated with this coordinated macroscopic motion is what we call the kinetic energy of the moving body. The kinetic and the potential energies associated with the random motion constitute the internal energy. So, when a body sliding on a surface comes to random motion of molecules in the body and in the surface, since we cannot control the motions of individual molecules, we cannot convert this random motion completely back to organized molecules. We cannot convert this random motion back to original. So, we can convert part of it, and this is what a heat engine does. So, if the second law were not true, we could power an automobile or run a power plant by cooling the surrounding air. Neither of these impossibilities violates the first law of thermodynamics. The second law, therefore, is not a deduction from the first, but stands by itself as a separate law of nature. The first law denies the possibility of creating or destroying energy, while the second law limits the availability of energy and the ways in which it can be used and convert. So now, we will now move on to the restating the second law of thermodynamics. So, have you ever wondered about the refrigerators? So, the analysis of refrigerators is the basis for an alternative statement of the second law of thermodynamics. So, heat flows spontaneously from hotter to colder bodies, never the reverse. A refrigerator does take heat from a colder to a hotter body, but its operation requires an input of mechanical energy of work. And generalizing this observation, we state that it is impossible for any process to have its sole result the transfer of heat and a cooler to a hotter body. So, in the second law, we have the engine statement. But here, when we restate or restating the second law of thermodynamics, we will now use, or we will call this the refrigerator statement of the second law, or it is also known as the Clausius statement. It may not seem to be very closely related to the engine statement. In fact, though the two statements are completely equivalent. For example, if we could build a workless refrigerator, violating the second or refrigerator statement of the second law, we could use it in conjunction with a heat engine, pumping the heat rejected by the engine back to the hot reservoir to be reused. So this composite machine would violate the engine statement of the second law because its net effect would be to take a net quantity of heat from the hot reservoir and convert it completely to work. But if we could make an engine with 100% thermal efficiency, in violation of the first statement, we could run it using heat in the hot reservoir and use the work output to drive a refrigerator that pumps, so heat from the cold reservoir to the hot. This composite device would violate the refrigerator statement because its net effect would be to take heat from the cold body or reservoir and deliver it to the hot reservoir without requiring any input of work. Thus, any device that violates one from the second law can be used to make a device that violates the other form. So, if violations of the first form are impossible, so are violations of the second. So, the conversion of the work to heat and the heat flow from hot to cold across a finite statements of the second law state that this process can be only partially reversed. So we could cite other examples. So gases naturally flow from a region of high pressure to a region of low pressure. Gases and miscible liquids left by themselves always tend to mix, not to unmix. The second law of thermodynamics is an expression of the inherent one-way aspect of all plant and animal life and of human technology. So, the second law of thermodynamics is of fundamental importance.